Alright, let's look at the homework 8, problem number 9. Alright, so it says that to show that the line y equals x is an oblique asymptote for the graph of f of x equals to x plus 3 over x, and summarize pertinent information obtained by applying graphing strategy and sketch the graph of f of x. Alright, so let's do that. Alright, so you have f of x, and when you look for oblique asymptotes, what you need to do is think about the x being really, really big, right? So if you look at this formula here, f of x is equal to x plus 3 over x. And you can see that 3 over x is going to be very, very, very small when x is extremely big. So this is really very similar to just x for large x value, right? So therefore, y equals x is the oblique asymptote. So y equals x is oblique asymptote. Let's say because x is undefined, that's not it. Is an oblique asymptote here. This is the reason here, right? So let's check the answer. Right, we got that. Right, so let's see. So domain of x. Right, so domain of this is going to be x equals 0 would be a bad number because that will make the denominator equal to 0. So all real numbers except x equals 0. So D is the answer. Right, so we got that. Alright, and next to the intercepts. Alright, so if you want to find x intercepts, we set this guy equal to 0. And so let's see, let's do that. Right, so if you set x plus 3 over x equal to 0. Right, and let's see if we can find anything here. So I don't like fraction. I'm going to multiply both sides by x. You get x squared plus 3, right, is equal to 0, right? But you can see that this equation is never true because x squared plus 3 is always positive. It's never equal to 0. So this never happens. So there's no x intercepts, right? So there's information here. X intercept is none, right? Is there a y intercept? Y intercept is set x equal to 0, but function is not defined there. So it's actually no x intercepts and then no y intercept. So answer is B. All right, so we get that. All right, we got that. All right, horizontal asymptote. Is there horizontal asymptote? But since we have an oblique asymptote, so as x gets larger and larger, it actually has a slant asymptote. So horizontal asymptote is none. And a vertical asymptote is obviously when x equals 1. So here, C is the right answer, right? So we check that, right? We got that, right? Let's see f prime. So we want to see, let's see, right? So we want to see increasing, decreasing intervals, right? So we're going to look at the derivative of this function. So f prime of x is equal to, right? Derivative of x is 1, right? Derivative of x over 3 is, again, we can rewrite it as 3 over x is 3x to the negative 1. So it's going to be negative 3x to the negative 2, right? So if you simplify this, let's see, it's going to be 1 minus 3 over x squared. Then I'm going to take the common denominator, so x squared minus 3 over x squared is equal to 0, right? So if you look at the, so we can factor this out. So the numerator is going to be x plus square root of 3 times x minus square root of 3. So we set that equal to 0. Which means that x is equal to plus or minus square root of 3, right? Then we can just do a number line, right? So 0, we have to eliminate it because the function is not defined there. And then you have a negative square root of 3, and we mark the positive square root of 3. Alright, so let's look at the sign of the derivative. Alright, so if you try something less than negative square root of 3, like negative 2 or something like that. Right, so it's a negative 2, so minus 3, so it's going to be negative 2 squared minus 3, so that's positive there. Right, anything between negative square root of 3 and 0, so we can try f prime of negative 1. Alright, so it's a negative 1 squared, 1 minus 3, so it's negative there. Alright, f prime of 1 is going to be still negative. F prime of 2 is going to be positive. Right, so we know that if you look at the function f, and this is going to be increasing there and decreasing there, and then these still decreasing there and increasing there. Right, so interval of increases, let's see, before square root of 3, a negative square root of 3, after square root of 3. Right, so increasing before negative square root of 3 and after square root of 3. And the decreasing on, let's see, it's including 0, so we don't like that one. The B might be a good one. So you have a before a negative square root of 3, after square root of 3, decreasing. See, it's eliminating at 0. So this is the correct answer. All right, let's check the answer. All right, we got that. All right, then let's see. We want to see if there's a local maximum or minimum. All right, so here. You can see that here, since the increasing turning into decreasing, so you have a local maximum at negative square root of 3, and here is a local minimum at square root of 3. All right, so let's check that. All right, local maximum at the negative square root of 3 and local minimum at the square root of 3, so D is the right answer. All right, let's check the answer. All right, we got that. All right, and let's see, concavity. So we have to take another derivative, right? So we take second derivative, right? So easiest way to take the derivatives is the first format. So f double prime of x is equal to derivative of 1 is 0, and derivative of that is negative 3 times negative 2, so positive 6, x minus 3, right? So you have a 6 over x cubed, right? So we want to see if it's positive or negative. So here, number line, and this becomes never 0. So I'm going to just put 0 there because a function is not defined. All right. So if you try and if you plug in anything negative, like negative 1, right? So obviously this is going to be negative. And f double prime of positive 1 is going to be positive. So we know that if you look at the original function, and here it's a concave downward before 0, and after that you have a concave upward. All right, so let's check that. All right, concave downward on the negative side and a concave upward on the positive side. So that's what we did, right? Concave down, all right? Concave downward, so B is the right answer. All right, let's check the answer. We got that. All right, there's an inflection point. Let's see, 0 inflection point. Yeah, so concavity changes at 0, but function is not defined at 0. So actually, there's no inflection point. So there is no inflection point, so C. All right, we got that. All right, so the graph is going to be, let's see, so what kind of graph are we looking for? So it's an increasing, decreasing, increasing, concave down, and a concave up. So let's look at that. All right, so this is not it. Increasing, decreasing, increasing. So this is promising. All right, this is increasing but not decreasing. That's not it. This is not increasing. So B is the only reasonable one. All right, check the answer. We got that. All right. That's it. I hope that this was clear.